Hi guys, I wanted to work this force problem for you. It says a 2 kilogram mass is pushed with a force of 50 newtons along a rough horizontal surface. The coefficient of friction between the surface and the block is 0.25. Find the following. We want to start with the frictional force. In order to do that, the first thing I'm going to do is draw a free body diagram. So the forces that act on my object are applied force, which is 50 newtons. We have friction. We have gravity. The mass of the object is 2 kilograms. So 2 times 9.8, that makes gravity 19.6 newtons. And we have normal force. Now, in order to find the frictional force, I need to, first of all, recall that friction is mu times the normal force. I have mu, but I don't have the normal force, so that brings me to the next thing to do. If I write out F net in the y direction equals m ay is 0, because the velocity of the thing in the y direction is 0. In other words, because there is no motion vertically, the normal force and the gravitational force are equal to each other. They must cancel. So we have normal minus gravity equals 0. So normal equals gravity, which equals 19.6 newtons. From there, I have mu, which is 0.25, and I have the normal force. So I can solve for friction. So friction is 0.25 times 19.6, giving us 4.9 newtons. All right, part B. Ask us to find the acceleration. So in looking at our free body diagram, guys, the object is going to go this way, so I'll call this direction of motion to be positive, so that makes applied force positive, friction negative, and we already know normal and gravity cancel. It makes normal positive and gravity negative, but in this case we're not worried about those. So we'll write out F net in the x direction. We have applied force that's positive and friction that is negative. That is equal to max. So A is going to be applied minus friction divided by mass. So acceleration is going to be 50, which is the applied force minus our 4.9 over the mass of 2. So acceleration becomes 22.55 meters per second squared. All right. Lastly, for part C, which I will do on, hopefully squeeze it right down here. Part C asks for the distance that the object traveled if its final velocity reaches 5 meters per second. So if I list all of my variables, v final, v initial, acceleration, displacement, and time. Initial is 0, final is 5, acceleration I found to be 22.55, displacement is question mark, and time I don't know but don't need, so we'll use the VF squared equation. And in solving for distance, we have final squared minus 0 squared over 2 times 22.55, and that gives us 0.55 meters. Hope that's helpful, guys. Thanks.